Percents, ratios, and proportions. We'll begin with a review of percents, decimals, and fractions to see how they're related. We know what decimals are, we know what fractions are. A percent basically takes a whole and divides it up into 100 different parts. So you can write a percent as a fraction by just putting it over 100. You can convert a percent as a decimal by technically dividing it by 100, or simply moving the decimal place 2 places to the left. For instance, 36% as a decimal is 0.36 if we divide by 100, or simply move the decimal place 2 places to the left. As a fraction, take that percent, 36, write it over 100, and of course reduces to 9 over 25. Beginning with a decimal and converting it into a percent, it's just basically the opposite operation. Instead of dividing by 100, we multiply it by 100. Instead of moving the decimal place 2 places to the left, we move it 2 places to the right, so it becomes 4.5%. As a fraction, that 4.5 over 100. In order to simplify this, though, we need to get rid of that decimal in the numerator. So we can multiply the numerator and denominator by 10, giving us 45 over 1,000, and then reduce it to 9 over 200. Beginning with a fraction, well, a fraction, nothing more than a division problem, so to convert it to a decimal, you just divide. 7 divided by 10 gives us 0.7. As a percent, 70%. Which brings us to a ratio. A ratio is just a comparison of two quantities, a comparison of two things. The way a ratio is written can be written a couple of different ways. For instance, a ratio 2 to 3. In fraction form, this is the form that we're primarily going to be using, the ratio 2 to 3. Or you can actually write it out, the ratio 2 to 3. Once again, it's just a comparison of two things. One ratio set equal to another ratio is called a proportion. For instance, the ratio 2/3 is equal to the ratio 6/9. Obviously, if we reduce 6/9, it gives us 2/3. An important property of proportions is you can cross multiply. In other words, if you multiply one numerator by the opposite denominator, it's going to be equal to the other numerator multiplied by the remaining denominator. For instance, 2 times 9 is going to be equal to 3 times 6. 18 is equal to 18. This cross multiplication process allows us to find missing values in a proportion. For instance, example 1, one ratio set equal to another ratio. In other words, one fraction set equal to another fraction is a proportion. Obviously, we have a missing value there, x, so we can cross multiply in order to solve it. X is going to be multiplied by 3, which obviously gives us 3x. The remaining numerator and denominator, 8 and 21, will be multiplied together, giving us 168. At this point, it's just a simple linear equation that we can solve. X is equal to 56. Example 2, x is in the first numerator, so that entire numerator, both those terms are going to be multiplied by the opposite denominator, the 4. So 4 times x plus 2 is equal to 3 times 12. Simplify. Solve the remaining equation. X is equal to 7. So now let's look at some more application problems involving ratios, proportions, and so forth. One application method is called the is over of method. This method helps us set up proportions. It's one ratio, is over of, equal to another ratio, a percent over 100. So of this proportion, there's 3 unknown values. The value for the is, the value for the of, and the percent. So what we have to do is read the problem and substitute in 2 of these 3 unknown values. That will allow us to solve for the remaining. So example 3, what percent of 80 is 24? So we set up this is over of method. We always have our 100 as our denominator there. Begin with what we're trying to find. We're trying to find the percent, so that's our variable x, which always goes over 100. The number next to the word of is 80, so that goes in the denominator. The number next to the word is 24. So substitute in those values. Now we have a proportion with only one variable. Once again, we can cross multiply and solve the remaining equation. X works out to be 30, and since it was a percent, we were trying to find 30%. Example 4, same problem. Use this is over of method, set up the proportion. In this case, we're given the percent. What we're looking for is the is, so that's going to be our x, and the of value is 53, so cross multiply here. 100x is equal to 31,800, so x is equal to 318. Example 5. Read example 5, understand what's going on. The answer might not be quite as obvious as you think it is if you read it too quickly. Average test on test 1 was an 88. Average score on test 2 was a 77. What percentage decrease from test 1 to test 2 did we have? Well, obviously dropped 11 points, but that's 11 points out of 100. Our original value here is the score for test 1, the 88. So we're trying to find a missing percent. So we set up is over of. X, of course, goes over 100. The original value was this average score of test 1, so that's our of 88. And what we're looking for is a percentage of decrease. Well, it went down 11 percentage points from 88 to 77, so we want to convert those 11 percentage points into a percent. So cross multiply. X is equal to 12.5%. Next type of application problem you're going to see is what's referred to as a mixture problem. The overall concept here, two things are being mixed together, and if you mix two things together, it's going to form something new. We'll call them solutions. The first thing we mix together is solution A, which is going to be mixed together with another solution, solution B. And if you mix these together, it's going to form something new, solution C. For each one of these three solutions, we're going to have a percent and an amount. So we want to read the problem. Should be pretty easy to recognize one of these mixture problems and fill in the information that we know. In this case, two things that are being mixed together, rum and cola. So solution A we'll call the rum. We know that it's 40% alcohol, so of course to convert that to a decimal. We do not know how much of it we need yet, so we'll leave that blank. Go on to solution B. The percentage of alcohol, obviously cola does not have any alcohol in it, so that would be 0. Once again, we do not know how much cola we need. And then solution C, we're going to form a 16% solution, and we need 5 liters of it. So of these 6 unknown values, 3% and 3 amounts, we know 4 of these values directly from the problem. Now we just have 2 unknown values we need to go back and substitute values in for. Well, we know we're going to have a variable, so we're going to let x simply equal the amount of solution A. Now, however much of solution A we have, solution B must be the balance between the total 5 liters and how much solution A we use. So basically, in order to determine how much solution B, you just take the total 5, subtract x, the amount of solution A, and that will leave us the amount of solution B. So already we have a skeleton of an equation, the amount of solution A plus the amount of solution B equal to the amount of solution C, that we can neaten up a little bit. 0.40x plus, well, 0 times anything is just 0, equal to 0.16 times 5 is 0.8. Solve the remaining equation. X works out to be 2. So not forgetting what we set x equal to in the problem, x was the amount of rum. So we had 2 liters of rum, which means we would need 3 liters of cola for a total of 5 liters. And the last category of application problems for this chapter, interest problems. There's a lot of different types of interest: simple interest, compound interest, continuous compound interest. Interest can be good, interest can be bad, whether you're paying interest or whether you're receiving interest. For these interest problems or investment problems, we're going to be dealing with simple interest, so you need to know the simple interest formula. I is equal to P times R times T, where I stands for the interest, P is the principal or the original investment, R is the rate, and T is time. So if you read the problem, once again, it's pretty easy to recognize one of these interest or investment problems. And like most of these interest problems you're going to see, actually 2 investments are being made, which means we're going to have 2 interests, 2 principals, 2 rates, 2 times. In other words, a lot of information. So one of the best ways to organize all this information is to set up a little table. We have the first investment, we have the second investment, and what we know about each, first of all, is their rates. We know one has a rate of 7%, the other has a rate of 9%. The time for each one is 1 year. We do not know how much was invested in each, but we know the total amount invested was $35,000. And we don't know how much interest was earned in each, but we know the total amount of interest between the two was $2,910. Now we just need to go back and fill in the blanks. Once again, obviously we need a variable. We're going to let x equal the amount invested in the first account. And keeping in mind that these two principals have to add up to $35,000, if we subtract how much was invested in the first account, that will leave us how much has to be invested in the second account. So $35,000 minus x for the second principal. Now we go back and substitute in the interest. Well, this is where we use the interest formula. The interest is equal to the principal times the rate times the time. So the first investment, its interest, is equal to x times 0.07 times 1, or 0.07x. The second interest, its principal times its rate times its time, 0.09 times 35,000 minus x. So once we complete the table, we have an equation right there in front of us. These three interests, the amount of interest from the first account, 0.07x, plus the amount of interest from the second account, 0.09 times 35,000 minus x, is equal to the total amount of interest earned, $2,910. So solve this equation. X works out to be 12,000, but once again we have to make sure we understand what that number actually stood for in the problem. X was the amount invested in the first account at the 7% rate. That means the amount invested in the second, 35,000 minus 12,000, is $23,000. Of course, the unit is dollars. We have it labeled correctly so that someone reading it knows exactly what we're telling them. So let's look at a few additional problems, a few more examples of these. Example 1, obviously another investment problem. So set up another table. The two interests in this case, 4% and 10%, and the time once again is 1. Total amount of interest earned, or total amount invested, $6,000. Total amount of interest earned, $500. So set it up. X, the amount invested in the first account. The total amount invested, $6,000 in this case, minus x is the amount invested in the second account. The interest, the first interest, principal times rate times time, 0.04x. The second, 0.10 times the 6,000 minus x, which gives us our equation right there, 0.04x plus 0.10 times 6,000 minus x is equal to 500. Solve this equation. X works out to be, do a little bit of rounding here, but $1,666.67. And once again, that was the amount invested at 4%, which makes the remaining $4,333.33 the amount invested at the 10% rate. Example 2, read the problem, understand what's going on, see if you can categorize what type it is. This is obviously another mixture problem. So same overall concept, solution A plus solution B is equal to solution C, and we have a percent and amount for each one of these. So just read the problem. Solution A is a 10% alcohol solution, so 0.10. Once again, we don't know how much of it we need. Solution B is a 30% alcohol solution. We don't know how much of it we need, but we're forming a 25% alcohol solution, and we know we need 100 gallons of it. So once we fill in the table, we have two unknown values here. The amount of solution A we'll call x. The amount of solution B will be the total, 100 minus x. Neaten up the equation a little bit. 0.10x plus 0.30 times 100 minus x is equal to 25, and solve for x. X works out to be 25, which was once again the amount of solution A, the 10% units, so 25 gallons of the 10%, which makes us need 75 gallons of the 30% solution. And example 3 deals with percentage increase, percent decrease. So this is another is over of problem. Set up your proportion. What we're looking for is the original size of the bag, so that's the value for of, the original size of the bag. We know the new size, the is the 12 ounces. And the percent was a 50% increase, so that means you have the original 100% of the bag and an additional 50%, so our percent here is actually 150. Cross multiply, 150x is equal to 1200, so x is equal to 8 ounces. The original size of the bag was out at 8 ounces, which makes sense. If we add 50% of that, 50% of 8 ounces is 4 ounces, which gives us that total of 12 ounces. So everything checks out.